We all love that blast of cold air from the AC on a scorching hot day, right? But what if I told you the fundamental way it works could be a whole lot smarter and way more efficient? Today, we're going to break down an innovative approach to cooling that feels, well, almost like magic. Let's get into it.
I know what you're thinking. Hold on, using heat to make things cooler. It sounds completely backwards, totally counterintuitive. But just stick with me, because that crazy idea is the actual secret behind a truly clever system that completely rethinks how we do air conditioning.
And here it is. This diagram is going to be our map for the next few minutes. I know it looks a little complicated at first glance, but don't worry, we're going to break it down step by step. We're just going to follow a single bit of air on its journey, starting over on the left as return air from a room, and we'll watch how it gets transformed into cool, comfortable air on the other side. So here's our game plan. We'll tackle this in a few key parts. We'll start with the two main stages of the process, what I'm calling the super sponge and the cooling core. Then we'll see how the system cleverly closes the loop and basically regenerates itself. And finally, we'll wrap up with why this is such a smart, green piece of technology.
Okay, so let's jump right into step one. A huge job for any air conditioner is just drying out the air. The problem is, traditional ACs try to cool and dehumidify at the exact same time. It's kind of like trying to pat your head and rub your stomach. Sure, it works, but it's not very efficient. This system is smarter. It tackles that sticky humidity first.
So, back to our map. The journey begins as that return air from the room enters this first chamber, the liquid desiccant dehumidifier. This is where the system gets really clever, by separating those two tasks.
So what in the world is a liquid desiccant? Well, just think of it as a super sponge. It's a special liquid, basically a type of salt solution, that is incredibly thirsty for moisture. So as the warm, humid air passes through, this liquid just pulls the water vapor right out. Simple as that.
And the outcome of this first step is so important. As you can see here, the humid air goes in, and what comes out the other side is very dry air. Now, it's still warm, but that's okay. We've solved the humidity problem completely without even touching the temperature yet. All right, now that we've got that dry air, the next step, actually cooling it down, becomes much simpler and way more efficient. And that brings us to the second stage of our journey, the cooling core. So, following our air on the map, it now moves from the dehumidifier into the second big chamber, the indirect evaporative cooler. This is where we finally drop the temperature.
The key word here is indirect. We all know that evaporating water has a powerful cooling effect. It's why sweating cools us down. But we just worked so hard to get moisture out of our air, the last thing we want to do is add it back in. So the system uses a separate secondary airstream from outside. It makes that air wet and cold, which in turn chills the walls of the chamber. Our dry air just flows through this chilled chamber, gets cold, but never actually touches the water. It's really ingenious.
And the final result? Perfectly cool, dry air is supplied right back into the room. We've done it. Our air particle has been transformed from warm and humid to cool and totally comfortable.
But hold on, the story isn't quite over. The real genius here is that this isn't a one-way street. It's an intelligent, continuous cycle that actually regenerates itself.
So let's just quickly recap the journey of the air we actually want to cool. It comes back from the room, gets dehumidified in the first step, is then chilled in the second step, and finally supplied back to the space. Simple and really effective.
Looking at our full map again, you can clearly see that clean loop for the conditioned air. But this diagram shows more than just that, right? It actually leaves us with one very important question.
What about our liquid desiccant? That super sponge is now totally saturated with water. Do we just throw it out? Of course not. This is where the system gets truly brilliant, and where that initial idea of using heat to cool comes full circle.
Look up at the top of the diagram. See that arrow labeled waste heat? This can be low-grade heat from something like solar panels, or even just waste from other industrial processes. That heat is used to essentially bake the water out of the liquid desiccant, regenerating it. The system uses free, discarded energy to wring out its own sponge so it's ready to absorb more humidity all over again.
So when you put this all together, you have a fundamentally smarter and greener way to create cool air. Let's just quickly summarize the key advantages here.
So, what are the big takeaways? Well, first, by separating dehumidifying from cooling, the whole process just becomes way more efficient. Second, it cleverly reuses waste heat, a free resource, to power its own regeneration.
Third, it cools without using those traditional energy-hungry compressors. And finally, the end result is simply fresh, dry, perfectly cooled air for your space.
You know, it really proves that the most efficient process is often the one that just uses what's already there. Instead of throwing away waste heat, this system sees it as valuable fuel to power its own cycle. It's just an elegant solution.
And that leaves us with a bigger question to chew on. This is just one example of using a waste product, in this case heat, to create real value. It makes you wonder, what other hidden waste streams are all around us, just waiting for an ingenious system to turn them into something useful?